Jupiter is the largest planet humanity has ever observed. We have seen it for centuries, measured its mass, mapped its clouds, and studied its internal structure in remarkable detail. Yet, there is one thing that has never happened. No human being has ever truly come close to Jupiter, and modern science tells us this is not because we lacked effort. Welcome to Bedtime Science Stories, a space for slow science where we do not chase headlines or seek excitement, but listen to the universe at its natural pace. In this video, we spend time with Jupiter, the largest planet in the solar system and a world that, despite how much we understand it, remains beyond human presence. This is not a story of conquest. It is a story of limits, of distance, and of why sometimes standing far away is the only way to understand clearly. Let the rhythm slow down now and begin with the first chapter. Jupiter holds a unique position in the structure of the solar system. It is not simply another planet orbiting the Sun. Its mass alone outweighs all the other planets combined, shaping the gravity, motion, and long-term stability of everything around it. From a distance, Jupiter appears familiar. A large striped sphere, a slow rotation, a presence we have seen in textbooks, diagrams, and night skies for most of our lives. Yet familiarity can be misleading. Jupiter did not form to resemble Earth, nor does it behave like any world we can stand on. It belongs to a fundamentally different category of planetary existence. While Earth, Mars, Venus, and Mercury are rocky bodies with solid surfaces, Jupiter is a gas giant, a world built not from ground and stone, but from layers of atmosphere that deepen endlessly as one descends. This difference is not cosmetic. It defines everything about how Jupiter exists and why human presence there remains out of reach. On a rocky planet, the idea of arrival makes sense. There is a surface. There is a moment when descent ends and standing begins. Human exploration, both historically and psychologically, is built around that concept. We travel, we land, we step out. Jupiter offers no such moment. There is no clear boundary where sky becomes ground. Its clouds thin gradually into denser gases, which compress into fluids under immense pressure. One could descend for thousands of kilometers and never encounter anything resembling a surface. There is no place to stand, no horizon to face, no ground to claim. Numbers whisper more than they speak. Even without extreme figures, the implications are simple. The human body evolved to exist between sky and ground. Remove the ground, and the assumptions that define human presence begin to dissolve. This is why the idea of setting foot on Jupiter does not apply. Not because technology has failed, but because the concept itself belongs to a different kind of world. Jupiter is not incomplete. It is not missing something Earth has. It is complete in its own way. From a structural perspective, Jupiter functions more like a small star that never ignited than a planet meant to host land or life. It radiates internal heat left over from its formation. Its atmosphere circulates continuously, driven not by sunlight alone but by energy rising from deep within. This internal dynamism makes Jupiter active, powerful, and persistent. Silence is also a kind of data. Despite this activity, Jupiter is not chaotic in the way we often imagine. Its storms follow stable patterns. Its cloud bands maintain long-term structure. Its rotation is steady and precise. This is not a hostile environment in the emotional sense. It is simply an environment that does not align with human biology. This distinction matters. When we say Jupiter is not meant for human presence, we are not assigning intention. The planet is not rejecting us. There is no barrier placed in defiance. There is only incompatibility. Much like deep ocean trenches on Earth are not hostile, but uninhabitable without assistance, Jupiter exists beyond the narrow conditions that human life requires. Pressure, chemistry, gravity, and atmospheric composition all move outside the window where biology can function naturally. Even advanced technology does not change this reality. Technology allows observation, it allows brief interaction, it allows measurement and understanding. But presence, in the sense of living or enduring, demands compatibility at a deeper level. Space rarely gives us simple answers. From a human perspective, this realization represents a quiet shift in how exploration is defined. For centuries, exploration meant arrival. Discovery meant stepping onto something new. Flags, footprints, settlements. Jupiter asks us to reconsider that framework. It suggests that understanding does not always require presence. That knowledge can come from distance, that some worlds are best known through listening rather than landing. This does not diminish human curiosity, it refines it. Jupiter's role in the solar system reinforces this perspective. Its immense gravity influences asteroid paths, shapes orbital resonances, and contributes to the long-term order of the planetary system. It acts less like a destination and more like an anchor, a stabilizing force whose importance lies not in being visited, but in being where it is. Seen this way, Jupiter becomes less of a challenge and more of a reference point. A reminder that the universe contains structures far larger and older than human ambition. Human presence is not the measure of importance. The more we learn about Jupiter, the clearer this becomes. Understanding grows alongside restraint. Each discovery does not bring us closer in a physical sense, but farther in perspective. There is a humility embedded in that process, not the humility of defeat, but of alignment, recognizing where we belong and where we do not. Jupiter stands as a world that does not ask to be conquered. It does not offer ground, shelter, or adaptation. Instead, it offers insight about formation, about scale, about limits, and perhaps about wisdom. As we begin this journey through Jupiter, it helps to release the expectation of arrival. This is not a story that moves toward landing, it is a story that moves toward understanding. And sometimes, standing far away is not a failure of reach, but a sign that we are finally learning where to stop. Jupiter is far from Earth, but distance in space is rarely understood through numbers alone. Kilometers and astronomical units describe separation mathematically, yet they fail to convey what the journey actually feels like. In space, distance is not just length, it is duration, silence, and the gradual thinning of everything familiar. Leaving Earth does not happen all at once. There is no sharp boundary where home suddenly disappears. Instead, the planet slowly recedes, becoming smaller, quieter, and less influential. Gravity loosens its grip. Signals take longer to return. The sense of immediacy fades. Numbers whisper more than they speak. Between Earth and Jupiter stretches a vast region of interplanetary space. It is not empty in the absolute sense, but it is profoundly sparse. A thin scattering of particles, occasional dust, fields and radiation that cannot be felt, only inferred. This region does not offer landmarks or scenery, it offers continuity. From a human point of view, this kind of space feels unfamiliar because it resists narrative. There are no events unfolding in quick succession, no moments of arrival or departure once the journey has begun. Days pass without visible change. Weeks drift by without milestones. The voyage becomes defined not by motion, but by waiting. In this environment, time behaves differently. Not physically different, but experientially altered. On Earth, time is segmented by routines, light cycles, and social rhythm. In deep space, time becomes uniform. One moment resembles the next. Movement continues, yet nothing appears to move. Silence is also a kind of data. As a spacecraft travels outward, the sun's influence changes. Light remains present, but it grows softer, less dominant. Shadows lose their sharpness. Illumination becomes more diffuse. The sun, once a commanding presence in the sky, gradually becomes a bright point rather than a source of warmth. This shift is subtle. There is no moment when sunlight suddenly disappears. Instead, brightness slowly loosens its hold. Energy arrives more gently. Surfaces cool more easily. The environment becomes quieter, not in sound but in intensity. For humans, light is more than illumination. It regulates sleep, attention, and emotion. As sunlight weakens, the cues that anchor biological rhythm fade as well. The journey outward is not only physical, but physiological in implication. Space rarely gives us simple answers. The spacecraft itself reflects this change. At launch, it is part of a loud, crowded system. Engines burn, communications flow constantly, telemetry streams in dense packets. As distance increases, activity simplifies. Commands become infrequent. Corrections are small and carefully timed. Most of the time, the spacecraft does nothing visible at all. It drifts. This drifting is not failure or loss of control, it is precision. The trajectory is carefully calculated, the motion continuous and intentional. Yet from a human perspective, it appears passive, a small object, moving steadily through an environment that offers no resistance. There is a particular solitude to this kind of travel, not loneliness in the emotional sense, but isolation in structure. The spacecraft carries no crew, no voice, no awareness, and yet it represents human intention. Every instrument aboard is a response to curiosity formed on Earth. Every antenna points back toward a place filled with sound, air, and life. The connection exists, but it stretches thin. Communication delays grow longer. Messages become echoes rather than conversations. Questions are asked long before answers can return. Numbers whisper more than they speak. As the spacecraft moves farther from the Sun, Jupiter begins to assert its presence subtly. Not visually at first, not as a shape or color, but as influence, tiny deviations in trajectory, gravitational hints felt before the planet is truly seen. A reminder that distance does not mean absence. Still, Jupiter remains far away for most of the journey. Weeks and months pass without any sense of approach. The planet does not gradually grow larger in the window. It waits. For a human observer, this challenges intuition. On Earth, travel is defined by progress markers, road signs, changing scenery, approaching horizons. In deep space, approach happens almost invisibly. The destination remains abstract until the final phase. Until then, the journey is defined by endurance rather than anticipation. Silence is also a kind of data. This silence carries meaning. It reveals how much of human experience depends on proximity. Sound requires air, motion requires reference, purpose often requires feedback. In the space between planets, feedback is delayed. The environment does not respond. The traveler, human or mechanical, must continue without reassurance. This is why distance itself becomes a barrier. Not because it cannot be crossed, but because crossing it demands patience beyond human instinct. It asks for a willingness to move forward without immediate reward. By the time Jupiter finally becomes visible as more than a point of light, the journey has already done its work. Earth feels distant in a way that cannot be measured. The sun feels smaller, the spacecraft feels alone. And perhaps that is the lesson embedded in the distance. Before we ever encounter Jupiter's gravity, radiation, or atmosphere, the journey itself has already redefined our expectations. It has taught us that reaching outward is not about speed or power, but about continuity, about moving steadily through an environment that offers no encouragement. As the spacecraft continues its silent approach, it carries with it a quiet truth that some distances are not meant to be conquered quickly. They are meant to be experienced slowly. And sometimes the space between worlds is not an obstacle to understanding, but the very condition that makes understanding possible. As a spacecraft moves closer to Jupiter, something begins to change long before the planet fills the view. There is no sudden visual signal, no audible warning, no clear line marking a boundary, yet the environment is no longer the same. Jupiter is surrounded by an immense magnetic field, far stronger than anything Earth produces. This magnetic field extends millions of miles into space, forming a vast region known as the magnetosphere. It does not look like a wall. It does not behave like a barrier in the familiar sense, but it defines where Jupiter's influence truly begins. The magnetosphere acts as a kind of invisible architecture, shaping the space around the planet. Within it, charged particles are guided, accelerated, and confined. These particles originate from the solar wind, from Jupiter's own atmosphere, and from material ejected by its moons. Once captured, they rarely leave. Numbers whisper more than they speak. This process creates Jupiter's radiation belts. They resemble Earth's radiation belts in concept, but not in scale. Around Jupiter, these regions are broader, denser, and far more energetic. They encircle the planet like layers of stored motion, continuously active yet entirely unseen. From a human perspective, radiation often carries an emotional weight. It is associated with danger, alarms, and urgency. In space near Jupiter, radiation is none of those things. It is calm, persistent, indifferent. There is no sound to announce its presence, no glow to mark its boundaries. A spacecraft can pass from a relatively quiet region into an intense radiation zone without any sensory change. Only instruments notice the difference. Silence is also a kind of data. At the atomic level, radiation interacts with matter in subtle but cumulative ways. High-energy particles strike atoms, displacing electrons, altering molecular bonds, and gradually degrading materials. In electronics, this can lead to corrupted signals, memory errors, and eventual failure. In biological tissue, it can damage cells in ways that accumulate over time. This damage does not happen all at once. There is no dramatic moment of collapse. Instead, the effects build slowly, quietly, and relentlessly. Each interaction leaves a trace, small enough to ignore in isolation, yet significant when repeated millions of times. For machines, this means shortened operational life. For humans, it means a fundamental incompatibility. Even with shielding, radiation remains difficult to block entirely. Materials can reduce exposure, but not eliminate it, and shielding adds mass, which introduces other constraints. Every solution creates a new limitation. Space rarely gives us simple answers. Jupiter's radiation environment is not malicious. It is a natural consequence of physics operating at planetary scale. The planet's rapid rotation and powerful magnetic field work together to energize particles to extreme levels. This energy is maintained continuously, not released in bursts. From Jupiter's perspective, this system is stable. From a human perspective, it is prohibitive. Spacecraft sent toward Jupiter are designed with this reality in mind. Their electronics are hardened. Their exposure is carefully managed. Trajectories are chosen to minimize time spent in the most intense regions. Even so, missions near Jupiter accept that degradation is inevitable. Instruments will age faster. Sensors will lose precision. Failures are expected, not exceptional. Numbers whisper more than they speak. For biological organisms, the challenge is far greater. Human cells repair damage constantly, but only within certain limits. Beyond those limits, repair mechanisms fall behind. Damage accumulates faster than recovery. This is not a flaw in biology, it is a boundary. Human life evolved under the protective shield of Earth's magnetic field and atmosphere. That shield filters radiation, moderates exposure, and maintains a narrow range of conditions where biology can thrive. Remove that protection, and the margin for survival shrinks rapidly. Near Jupiter, that margin disappears. Even brief exposure in the planet's strongest radiation zones would exceed levels the human body can tolerate safely. Extended presence would lead to progressive cellular damage that no technology can fully prevent. This reality shifts how we think about exploration. Reaching Jupiter is not a matter of courage or engineering ambition. It is a matter of compatibility between environment and organism, and compatibility cannot be forced. Silence is also a kind of data. There is a quiet lesson in how radiation behaves near Jupiter. It does not announce itself. It does not escalate to demand attention. It simply exists, continuously shaping what is possible. This challenges human intuition. We often expect danger to be loud or visible. In space, many of the most decisive factors are neither. Radiation near Jupiter does not create spectacle. It creates limits. Understanding those limits has refined scientific priorities. Rather than attempting sustained presence, exploration focuses on observation. Flybys instead of landings. Remote sensing instead of habitation. This approach is not a retreat. It is an adaptation. By respecting the invisible structures around Jupiter, science gains clarity rather than losing opportunity. Data is gathered carefully. Questions are framed realistically. Expectations align with physical law. Space rarely gives us simple answers. As we move closer to Jupiter in concept, the planet reveals itself not through resistance but through consistency. Its radiation environment has persisted for billions of years. It is not a temporary obstacle. It is part of what Jupiter is, and that understanding brings a certain calm. There is no urgency to overcome this barrier. No need to rush towards solutions that physics does not permit. The universe is not withholding access. It is describing conditions. In that sense, Jupiter is not closed to us. It is transparent. It shows us clearly and without emotion where human presence ends and observation begins. And sometimes, recognizing that boundary is not a loss, but a deeper form of knowledge. To understand why human presence cannot exist on Jupiter, one must first let go of a familiar expectation. There is no surface waiting beneath the clouds, no ground hidden just beyond sight. No moment when falling becomes standing. Jupiter does not offer a place to arrive. Unlike rocky planets, where atmosphere rests above solid ground, Jupiter's atmosphere is the planet. What appears as sky from a distance is not a layer covering something else. It is the beginning of a vast, continuous structure that deepens without interruption. From afar, Jupiter's clouds form soft bands of color gently wrapped around the planet. They look layered, almost decorative. But these clouds are not shallow. They are the uppermost expression of an environment that extends thousands of kilometers downward. Numbers whisper more than they speak. As one moves deeper into Jupiter's atmosphere, clouds do not give way to land. They give way to more clouds. Each layer forms under different temperatures and pressures, composed of different materials, shaped by different dynamics. At the highest visible levels, thin clouds of ammonia drift in cold, low-pressure conditions. Below them lie denser layers where water and other compounds condense. Still deeper, gases thicken, motion slows, and the distinction between atmosphere and interior begins to blur. There is no clear boundary where one can say this is where the atmosphere ends. For humans, this absence of a surface is more than a technical challenge. It removes a fundamental reference point. Human orientation depends on ground. We measure height, depth, and movement relative to something solid. On Jupiter, there is no such reference. The experience of descent would feel unlike anything known on Earth. There would be no moment of impact, no confirmation of arrival, only continued movement into denser and denser surroundings. Silence is also a kind of data. As depth increases, pressure builds gradually at first, then relentlessly. Gas molecules are forced closer together. Movement becomes constrained. Structures that function comfortably in Earth's atmosphere would begin to deform, then fail. This pressure does not announce itself. It does not strike suddenly. It accumulates quietly, steadily, as gravity draws material inward. For technology, this means limits that arrive without warning. For biology, it means immediate incompatibility. Human bodies are adapted to a narrow pressure range. Even modest deviations require assistance. Beyond that range, survival becomes impossible regardless of preparation. On Jupiter, pressure exceeds those limits long before any solid state is encountered. Space rarely gives us simple answers. The idea of going down loses meaning in this environment. On Earth, descent implies an endpoint, a floor, a bottom. On Jupiter, descent is continuous. One can imagine falling through clouds that gradually thicken into fluid-like gas, where resistance increases but never resolves into solidity. The sensation would not be of approaching a destination, but of moving deeper into something without boundaries. This challenges how humans conceptualize exploration. We are accustomed to journeys with conclusions. Mountains have summits, oceans have seafloors. Jupiter offers neither. It is often compared to an ocean, and the comparison is useful, but incomplete. Earth's oceans, though vast, are finite. They rest on crust. They have depth limits defined by geology. Jupiter's atmosphere resembles an ocean without shores or bottom. A continuous medium shaped by gravity and heat rather than containment. Numbers whisper more than they speak. As pressure increases, the behavior of matter changes. Gases no longer act like gases. They become compressed into dense fluids. Chemical interactions shift. Physical laws still apply, but their outcomes feel unfamiliar. In these depths, human concepts of atmosphere and interior merge. There is no clear line where one ends and the other begins. Only gradual transformation. For a spacecraft, this environment presents an unavoidable progression. Descent leads not to landing, but to destruction by pressure and heat. There is no safe depth to pause, no stable layer to inhabit. This is not because Jupiter is hostile, it is because Jupiter is consistent. Silence is also a kind of data. The planet does not provide signals meant to be interpreted as warnings. It does not resist entry. It simply continues being what it is, regardless of who approaches. For humans, this creates a quiet realization. Exploration is not always about going farther inward. Sometimes it is about knowing when inward movement stops making sense. Understanding Jupiter's atmosphere shifts focus away from presence and toward observation. Data gathered from above reveals more than any attempt to descend ever could. Patterns become visible. Dynamics emerge. Relationships between layers can be studied without crossing into destructive depths. Space rarely gives us simple answers. There is also something humbling in this structure. Jupiter reminds us that not all worlds are built for occupation. Some are built for motion, circulation, and balance at scales far beyond human experience. This does not diminish their value. It expands it. From a distance, Jupiter's atmosphere tells a story of formation, energy, and time. A story written not in landscapes, but in gradients. Not in surfaces, but in depth. For humans, listening to that story requires restraint. It requires abandoning the expectation of arrival and accepting continuous descent as an abstract concept, rather than a physical goal. As we reflect on Jupiter as an ocean without shores, a pattern becomes clear. The planet does not hide its nature. It reveals it steadily, layer by layer, to those willing to observe without intrusion. And perhaps that is the lesson embedded in its endless atmosphere. Some worlds are not meant to be reached. They are meant to be understood from afar, where depth can be measured without falling, and presence is replaced by perspective. Beneath the visible clouds of Jupiter, the familiar behavior of matter begins to change, not abruptly, not violently, but gradually as pressure and temperature increase together. Hydrogen, the simplest and most abundant element in the universe, dominates Jupiter's interior. Near the upper atmosphere, hydrogen behaves as a gas, light and mobile, responding easily to temperature and motion. But as depth increases, gravity compresses this gas more tightly. Molecules are forced closer together. Their freedom to move independently diminishes. Numbers whisper more than they speak. At a certain point, hydrogen no longer behaves like a gas at all. It becomes a dense fluid, flowing rather than drifting. This transition does not occur at a single boundary. There is no sharp line where gas suddenly turns into liquid. Instead, the change unfolds gradually across immense depths. This process is known as a phase transition. On Earth, phase transitions feel familiar. Water freezes into ice. Ice melts back into liquid. Steam condenses into droplets. Inside Jupiter, the same principles apply, but under conditions far beyond anything found on our planet. Pressure increases to levels that compress hydrogen into states rarely observed in laboratories. Temperature rises alongside pressure, preventing solidification while forcing density upward. The result is hydrogen that flows like a liquid, conducts heat efficiently, and behaves in ways that challenge everyday intuition. Silence is also a kind of data. As hydrogen is compressed even further, it enters one of the most unusual states known in planetary science: liquid metallic hydrogen. In this state, hydrogen atoms are packed so tightly that their electrons move freely, much like in a metal. The material conducts electricity. It responds to magnetic fields. It participates directly in the generation of Jupiter's powerful magnetosphere. This is not metal in the traditional sense. There is no hardness, no shine, no solid structure. It is metallic in behavior, not appearance. Space rarely gives us simple answers. Liquid metallic hydrogen exists naturally only under extreme pressure and temperature. On Earth, scientists can create tiny samples for brief moments using powerful experiments, but these conditions are fleeting and limited. Inside Jupiter, they persist naturally, maintained by the planet's immense gravity. This makes Jupiter not just a subject of study, but a setting where physics unfolds continuously at scales we cannot reproduce. In these depths, the distinction between phases becomes less clear. Gas, liquid, and metal blend into a continuum. Matter changes smoothly rather than abruptly. The familiar categories used on Earth lose precision. For humans, this blurring of boundaries challenges how we think about materials. We are accustomed to sharp distinctions: solid ground, liquid water, gaseous air. Jupiter reminds us that these distinctions are contextual. They depend on environment, not essence. Numbers whisper more than they speak. The existence of liquid metallic hydrogen has profound implications. It helps explain Jupiter's immense magnetic field. As the electrically conductive fluid moves and circulates, it generates currents. Those currents sustain a magnetosphere that extends far into space. This process occurs continuously, without pause. There is no switch to turn it on or off. It is a natural outcome of Jupiter's internal structure. From a human perspective, this reveals something important about planetary systems. Complex behavior does not require intention or design. It emerges naturally when conditions align. Silence is also a kind of data. These deep layers also illustrate why human presence remains impossible. The pressures required to maintain liquid metallic hydrogen would crush any known structure. Temperatures would overwhelm biological processes instantly. This is not a limitation of technology alone. It is a boundary set by physics. Even imagining human survival here requires abandoning biological assumptions. Cells, proteins, and chemical reactions that define life on Earth cannot function under these conditions. No amount of shielding or adaptation changes that reality. Jupiter's interior does not reject life. It simply operates under rules that life does not follow. Space rarely gives us simple answers. Despite this, Jupiter's interior offers remarkable value to science. It serves as a natural laboratory, where theories about matter, magnetism, and planetary formation can be tested against reality. By observing Jupiter's magnetic field, gravity, and heat flow, scientists infer the behavior of materials far below the clouds. These observations refine models not only of Jupiter, but of giant planets throughout the galaxy. Many exoplanets discovered around other stars resemble Jupiter more than Earth. Understanding Jupiter helps us understand them. In this sense, Jupiter's interior is not distant or irrelevant. It informs how we think about planetary systems on a universal scale. Numbers whisper more than they speak. For humans, there is also a quieter lesson here. Jupiter demonstrates that not all knowledge comes from direct access. We do not need to enter the planet to understand its processes. Observation, patience, and inference provide insight without intrusion. This approach contrasts with the instinct to go deeper, to push inward physically. Jupiter invites a different kind of engagement, one that values distance as a tool rather than a barrier. Silence is also a kind of data. As we consider the phase transitions within Jupiter, a pattern emerges. The planet is not layered like a building with floors. It is graded, continuous, and fluid. Each depth flows naturally into the next. This continuity mirrors something human as well. Understanding often arrives gradually, not in moments of revelation, but through sustained attention. Jupiter does not reveal itself quickly. It reveals itself steadily to those willing to observe over time. In recognizing Jupiter as a natural laboratory of extreme physics, we also recognize our role as observers. We do not need to stand inside these depths to learn from them. We only need to listen carefully. And sometimes, the most meaningful discoveries occur not where we can go, but where nature continues its work without us, quietly demonstrating how matter behaves when the universe sets the conditions. When we look at Jupiter from a distance, the first thing we notice is motion. Not the motion of the planet around the sun, but the movement etched across its surface. Bands of light and dark wrap around the globe, sliding past one another in opposite directions. They appear calm, almost painted, yet they never stop moving. These cloud bands are not decorations. They are the visible expression of a deep and persistent circulation system, one that has been operating for a very long time. Each band marks a region where winds flow steadily, guided by the planet's rapid rotation and immense scale. Numbers whisper more than they speak. On Jupiter, neighboring bands move in opposite directions, creating sharp boundaries without chaos. The winds are fast, but they are not random. They follow paths shaped by physics rather than impulse. This pattern repeats across the planet, giving Jupiter a sense of order even in constant motion. For humans, wind is often associated with change. Weather fronts arrive and pass, storms form, peak, and fade. On Earth, motion usually signals transition. On Jupiter, motion signals continuity. Some of Jupiter's storms persist not for hours or days, but for decades and longer. They do not wander unpredictably. They maintain shape and position within the broader flow of the atmosphere. Their longevity reflects stability rather than intensity. Silence is also a kind of data. This stability arises from the source of Jupiter's energy. Unlike Earth, where most atmospheric motion is driven by sunlight, Jupiter generates a significant amount of heat from within. This internal heat is a remnant of the planet's formation, slowly released over time. The heat rises through the atmosphere, creating convection. Warmer material moves upward, cooler material sinks downward. This cycle repeats continuously, supplying energy to the winds without exhausting it. Because the energy source is internal and steady, the system does not depend on day and night cycles. There is no seasonal reset, no pause. The atmosphere remains active, sustained by a constant flow of heat from below. Space rarely gives us simple answers. Jupiter's rapid rotation adds another layer of structure. The planet spins much faster than Earth, completing a rotation in less than half a day. This speed stretches atmospheric motion into long, narrow bands. Winds are guided into paths that circle the planet rather than crossing it. The result is a system that looks dynamic but behaves predictably. Energy is redistributed efficiently. Motion remains organized. For human observers, this challenges assumptions about turbulence. We often equate movement with disorder. Jupiter demonstrates that constant motion can coexist with long-term stability. Numbers whisper more than they speak. Even Jupiter's largest storms follow this principle. They draw energy from surrounding flows and internal heat, yet they remain integrated within the broader atmospheric system. They do not tear the atmosphere apart. They become part of it. This integration is possible because Jupiter's atmosphere is deep, extremely deep. Storms are not shallow features. They extend far below the visible clouds, anchored by layers that move more slowly and steadily. Depth creates memory. On Earth, storms dissipate when they lose access to energy. On Jupiter, energy is continuously available. The atmosphere does not need to reset. It evolves gradually. Silence is also a kind of data. For humans, there is something instructive in this endurance. Jupiter does not rush toward equilibrium. It maintains balance through ongoing motion rather than stillness. This offers a different model of stability, one that does not depend on rest but on flow. In daily life, humans often seek calm by stopping movement, by reducing activity, by creating stillness. Jupiter suggests another possibility. That calm can also emerge from steady, predictable motion, from systems that know where to move and how to return. Space rarely gives us simple answers. The planet's internal heat also explains why its atmosphere remains active far from the Sun. Even as sunlight weakens with distance, Jupiter continues to circulate energy. Its winds do not slow. Its patterns do not fade. This independence from external energy reinforces Jupiter's self-sufficiency. The planet does not rely on its environment to maintain activity. It carries its momentum within. For human exploration, this has practical implications. An environment driven by internal heat remains active regardless of external conditions. There is no quiet window, no season of rest. But for understanding, it offers clarity. Jupiter's behavior can be studied as a system largely governed by internal processes rather than external variation. Numbers whisper more than they speak. From a distance, Jupiter's atmosphere appears almost serene. The colors are soft. The transitions are smooth. Motion unfolds slowly across the planet's vast surface. Up close, the same atmosphere is powerful, layered, and persistent. Yet it remains ordered. This balance between energy and structure is what defines Jupiter's atmospheric character. It is not a world of sudden change. It is a world of continuous adjustment. Silence is also a kind of data. As we consider the enduring dance of wind and heat on Jupiter, a larger pattern becomes visible. The planet does not seek stillness, it seeks balance through motion. For humans, this reframes how we interpret activity. Movement does not necessarily mean instability. Noise does not always signal disorder. Jupiter moves constantly, yet remains coherent. Its winds do not escalate into chaos. They return, repeat, and persist. In that sense, Jupiter's atmosphere reflects a quiet lesson, that systems can be both active and calm, dynamic and stable. And perhaps that is why observing Jupiter feels reassuring rather than overwhelming. Its motion is not a warning, it is a rhythm, a reminder that some worlds remain balanced not by stopping, but by continuing, steadily and without urgency, in a pattern that has lasted far longer than human attention. Gravity is often described as a force, but on the scale of Jupiter, it feels more like a quiet rule that everything follows. It does not announce itself. It does not change quickly. Yet over time it shapes motion, position, and stability across vast distances. Jupiter's gravity is strong, not in a sudden or dramatic way, but in a persistent one. Its mass bends space around it, creating a region where paths curve gently inward. Objects do not fall toward Jupiter as if pulled by a rope. They drift, gradually adjusting their trajectories, responding to an influence that is always present. Numbers whisper more than they speak. For spacecraft, this gravity defines what is possible. Approaching Jupiter requires careful planning, not because the planet is aggressive, but because its pull is deep. Once a craft enters Jupiter's gravitational domain, leaving again demands energy. Not a burst of power, but a sustained commitment of momentum in the right direction. This is why escaping Jupiter's vicinity is difficult, not impossible, but costly. Energy must be added continuously to climb out of the planet's gravitational well. Every maneuver must be precise. Every decision carries long-term consequences. From a human perspective, gravity often feels personal. On Earth, it gives weight to the body. It keeps feet on the ground. It defines up and down. Around Jupiter, gravity becomes impersonal and structural. It does not act on individuals. It organizes systems. Silence is also a kind of data. Jupiter's gravity extends far beyond the planet itself. It reaches into surrounding space, shaping the orbits of moons, influencing the paths of asteroids, and contributing to the overall architecture of the solar system. This influence unfolds slowly. There are no sudden corrections. Instead, Jupiter's gravity nudges objects into stable patterns over long periods of time. Many of the small bodies that pass through the outer solar system encounter Jupiter's gravity at some point. Some are redirected. Some are captured briefly. Some are guided into new orbits. This process does not require intention. It is simply the result of mass and motion interacting according to physical law. Space rarely gives us simple answers. Because of this role, Jupiter is sometimes described as a guardian of the inner solar system. Its gravity alters the paths of incoming objects, reducing the frequency of impacts closer to the Sun. This is not protection by design. It is a byproduct of position and mass. For Earth, this has been quietly significant over geological time. Fewer catastrophic impacts mean greater long-term stability. Life benefits from consistency, even when that consistency comes from distant forces. Numbers whisper more than they speak. It is important, however, not to misunderstand Jupiter's gravity as a trap. Gravity does not imprison. It invites motion to follow curves instead of straight lines. Objects orbit Jupiter not because they are captured unwillingly, but because their velocities align with the planet's gravitational field. Change the velocity and the path changes. The rules remain the same. This distinction matters for how we think about control and limitation. Jupiter does not hold things in place by force alone. It maintains order by providing a stable framework in which motion can persist. Silence is also a kind of data. For humans, this reframes how power is understood. We often associate strength with action, with visible exertion, with immediate results. Jupiter's gravity demonstrates a different form of strength, one that operates continuously without display, one that influences outcomes over millions of years. This kind of influence does not demand attention, it accumulates quietly. The solar system we observe today reflects this accumulation. Orbital resonances, stable paths, predictable motions that allow planets and moons to coexist without constant disruption. Jupiter's gravity contributes significantly to this coherence. It acts as a stabilizing presence, not by stopping motion, but by shaping it. Space rarely gives us simple answers. For exploration, this gravity imposes practical limits. Sending spacecraft near Jupiter requires accepting that every approach changes future options. The planet's pull cannot be ignored or overridden casually, yet those same gravitational properties enable precise navigation. Gravity assists, orbital insertions, carefully timed flybys that borrow momentum rather than expend it. Here again, gravity is not an obstacle, it is a structure. Numbers whisper more than they speak. From a human point of view, there is something reassuring about this consistency. Gravity does not surprise, it does not change its rules. Once understood, it behaves exactly as expected. In a universe filled with uncertainty, gravity offers reliability. Jupiter exemplifies this reliability at scale. Its gravity has remained steady since the early formation of the solar system. While surfaces change and atmospheres evolve, mass endures. This endurance is what allows order to persist. Planets remain in orbit. Moons trace familiar paths. Time unfolds without sudden rearrangement. Silence is also a kind of data. As we consider Jupiter's gravity, a quiet realization emerges. The most powerful forces in the universe do not need to dominate attention. They simply need to remain consistent. Jupiter does not impose order through control. It allows order to arise naturally through attraction. For humans, this offers a subtle lesson. Stability does not always come from restraint or resistance. Sometimes it comes from allowing movement to occur within clear boundaries. Jupiter's gravity does not halt motion, it gives motion a shape. And perhaps that is why, despite its immense pull, Jupiter does not feel oppressive. It feels steady, a reminder that order in the universe is not enforced by force alone, but maintained through quiet, persistent alignment between mass, motion, and time. When people speak about the future of space exploration, technology often takes center stage. More powerful engines, smarter computers, stronger materials. It is easy to imagine that with enough innovation, any destination becomes reachable. Yet when we consider Jupiter, a quieter truth begins to surface. The primary limit is not machinery, it is biology. Humans evolved on Earth within a narrow band of conditions that shaped every part of our physiology. Gravity that pulls gently but consistently. An atmosphere with a precise mix of gases. Temperatures that fluctuate within tolerable ranges. A magnetic field and atmosphere that shield life from harmful radiation. These conditions are not incidental, they are foundational. Every cell in the human body assumes their presence. Bones maintain strength under Earth's gravity. The heart circulates blood according to known pressures. The brain regulates sleep, balance, and cognition using cues tied to light, time, and gravity. Numbers whisper more than they speak. When we move away from Earth, these assumptions begin to fail. In microgravity, muscles weaken and bones lose density. Radiation exposure increases. Biological rhythms lose alignment. Technology can mitigate some of these effects temporarily. Exercise systems slow muscle loss. Shielding reduces radiation exposure. Careful scheduling supports sleep cycles. But mitigation is not adaptation. Space rarely gives us simple answers. Jupiter represents an environment far beyond the range where mitigation is sufficient. Its gravity, radiation, pressure, and atmospheric composition move so far outside human tolerance that survival becomes impossible regardless of technological assistance. This is not a failure of imagination. It is a consequence of how life works. Biological systems are robust within their evolved range, but fragile outside it. They rely on precise chemical reactions, stable molecular structures, and controlled energy transfer. Disrupt those conditions too severely, and life processes cannot continue. No material can change that. Technology excels at observation. It extends our senses. It allows us to measure, record, and analyze environments we cannot enter. Probes can survive where humans cannot. Instruments can function under pressure, heat, and radiation far beyond biological limits. Data can be transmitted across vast distances without concern for comfort or safety. Silence is also a kind of data. This distinction between observation and presence is crucial. To observe is to interact indirectly. To be present is to exist within an environment continuously. Jupiter allows the former but not the latter. This does not diminish technological achievement. In fact, it highlights its precision. The ability to design machines that operate reliably in extreme conditions reflects deep understanding of physics and engineering. But it also clarifies what technology is not meant to do. It is not meant to rewrite biology. Some limits cannot be engineered away because they are not technical problems. They are questions of compatibility. Numbers whisper more than they speak. Human history often frames progress as overcoming limits, crossing oceans, climbing mountains, reaching the moon. These achievements reinforce the belief that persistence and ingenuity can solve any challenge. Jupiter challenges that narrative gently. It suggests that some boundaries are not barriers to be broken, but realities to be understood. This distinction matters because it reshapes how knowledge is valued. Knowing does not always require being there. Understanding does not demand physical presence. For much of science, insight comes from distance. Astronomy itself exists because observation can occur without contact. Light, gravity, and radiation carry information across space. Jupiter speaks to us through these signals. Its mass alters trajectories. Its magnetic field shapes charged particles. Its atmosphere emits patterns of heat and motion. Listening carefully reveals more than any attempt to enter ever could. Space rarely gives us simple answers. From a human perspective, accepting biological limits can feel like resignation. But in science, acceptance often marks progress. It allows resources to be directed wisely. It encourages deeper questions rather than futile effort. It aligns curiosity with reality. This alignment does not reduce ambition, it refines it. By acknowledging that humans cannot exist on Jupiter, exploration becomes more focused. The goal shifts from presence to comprehension, from arrival to interpretation. Silence is also a kind of data. There is also a human comfort in this realization. The universe does not expect us to occupy every place. Value is not measured by presence. Earth remains special, not because it is rare, but because it is compatible. Life flourishes here because conditions align naturally. Jupiter reminds us that most of the universe does not share those conditions. And that is not a flaw. It is diversity. Different worlds serve different roles. Some host life, some shape systems, some reveal physics at scales beyond experience. Jupiter does the latter with quiet consistency. Numbers whisper more than they speak. The difference between knowing and being there becomes clear in this context. To know Jupiter is to understand its behavior, influence, and structure. To be there would require becoming something other than human. Science does not ask for that transformation. It asks for observation, patience, and respect for natural boundaries. In that sense, Jupiter teaches restraint as a form of wisdom. Silence is also a kind of data. As this chapter comes to rest, one idea remains steady. Limits are not always obstacles. Sometimes they are guides. They point us toward methods that work, questions that matter, and expectations that align with reality. Jupiter does not deny us access. It clarifies what access means. And perhaps the deepest understanding comes not from pushing beyond every boundary, but from recognizing which boundaries define who we are and which worlds are meant to be known without being entered. Jupiter was never meant to be a destination, not in the way humans usually understand that word. It does not wait to be reached, entered, or occupied. It simply exists, following its own physical rules with steady consistency. For a long time, distance has been framed as a problem to solve, a measure of how far we still have to go. But when it comes to Jupiter, distance is not a failure, it is information. Numbers whisper more than they speak. The space between Earth and Jupiter tells us something important, that not every world invites presence. That understanding does not always require proximity. Some environments reveal themselves most clearly when we remain far enough away to observe without interference. Jupiter continues its motion regardless of human attention. It rotates, it circulates heat from deep within. Its gravity maintains order among moons and distant objects alike. Nothing about this process depends on being witnessed. Silence is also a kind of data. There is something quietly reassuring in that. The universe does not rush. It does not adjust itself to human timelines or expectations. It unfolds according to principles that remain steady over immense spans of time. Space rarely gives us simple answers. As humans, learning often begins with movement. We approach, we touch, we try to be present. But Jupiter teaches a different kind of learning. One rooted in listening rather than advancing, in observing patterns rather than seeking arrival, in accepting that some truths are clearer when we do not attempt to cross every distance. Jupiter does not close itself to us. It shows us where we stand. And perhaps that is enough. As the planet continues its quiet work, holding structure, releasing heat, and shaping space around it, we are reminded that understanding does not always mean going closer. Sometimes it means knowing when to remain still,